This video will cover the use of the XProps function in Labview called XPR wetair underscore all tptd. To start, we will have to reference the XProps DLL file specific to Labview in order to use this function. In the block diagram window, type in call library in the search bar at the upper right hand corner, go down to call library function node, and drag and drop it on your screen. Double-click on the icon and navigate to the file called xprops.lbv.dll on your computer to add this file to the path. In the drop-down menu for function name, select xpr wetair underscore all tptd. There are going to be 5 inputs for this function. The first is input code. This function will take in the temperature and pressure, but the third parameter is different. The input code will determine if the last parameter is relative humidity, dew point temperature, or what's bulb temperature. Set this value to 0 for the last parameter to take in a value for relative humidity, 1 if the last parameter should be a dew point temperature, and 2 for a wet bulb temperature. This will be casted as an integer. The next 2 inputs are temperature and pressure. These will both be casted as doubles. The third input I'm going to name input 3 since this parameter changes depending on which code is inputted. Again, this will be a double. The last input will be unit, which states what units this function uses, which will strictly be SI units. It is casted as a string type. There will be 10 total output values. Wet bulb temperature, dew point temperature, humidity ratio, relative humidity, enthalpy, density, specific heat, static viscosity, dynamic viscosity, and an error. Most of these are casted as doubles, except for the error parameter, which is casted as a signed 32-bit integer. All the output parameters should pass pointer to value. At the bottom under function prototype, you can check to see if all the parameters, both input and output, have been declared. There should be 15 total parameters. Now we shift to the front panel window. Here, I have already set up a title, which I have called Air Properties for Moist Air, and organized 2 columns for the inputs and outputs. As a reminder, the inputs should be created under Control, while the outputs should be created under Indicator. Most of these variables should go under Numeric in the Controls panel, with the exception of the Units parameter, which should go under String and Path. Each parameter should also reflect the same variable type as declared on the block diagram from before. For example, input code was initially declared as an integer type, so we have to go into Properties and set it as a 32-bit integer. This also goes for the error value. This prevents errors stemming from mismatched data types. Returning to the block diagram, I have wired most of the input and output blocks to the central table. As mentioned previously, this function only allows for SI units, so we will have to make the appropriate conversions so that the input units are correct. Assuming the temperature is initially given in degrees Celsius, we will have to add 273.15 to convert temperature to Kelvin. Also, assuming that pressure is given in kilojoules, we have to multiply by 1000 to convert kilojoules to joules. These conversions can be done by going to the numeric option under Programming on the function panel. Right-clicking and selecting Create Constant will allow us to specify how much we want to add for our conversion. We then wire this conversion into our diagram. We do the same for the outlet, wet bulb, and dew point temperatures, subtracting 273.15 to convert them to degrees Celsius again. Now everything should be set up and ready to receive values on the front panel. If you have further questions, please contact us at support@optimizedthermalsystems.com.